attending today's webinar. As Ian had already introduced, my name is Anja Sørensen. I'm the HSE lead for EUB3730, and I'm happy to present to you our webinar on maximum safe handling temperatures. This has actually been a topic that has been identified really early by our HSE committee when we started planning before we had our first webinars at all, because it's such an important topic. The aim of today's webinar is to familiarize you with these maximum safe handling temperatures that EUB3730 is recommending for a long time already, what the status of these maximum safe handling temperatures are, what's the background behind this, and what are the consequences of these maximum safe handling temperatures. Why is it important to talk about maximum safe handling temperatures? Well, bitumen is usually handled hot, while its application is at, or its final use is at ambient temperatures. The handling is done at elevated temperatures. That can cause burns to the skin and the eyes. We do have some recommendations on how to act then. Bitumen is not a hazardous substance as such, but because it is transported at temperatures above 100 degrees C but below its flash point, it's classified as a dangerous good in terms of transportation. There's some technical impact from bitumen being handled hot, and that is the combination of high temperatures and air causes bitumen aging, and that has an effect on the technical performance of the end use. And most importantly for today's webinar is the fact that bitumen, as other substances, can emit particles into the environment, and that causes exposure of workers at workplaces. This exposure is sometimes called occupational exposure, sometimes it's called workplace exposure. We are not going to dig into the details of the legal terms of that, but there is something that is related to exposure of workers, and that is important for EUB3730 and its members because we want workers to work safely with bitumen and its applications. So for a couple of years already, decades, and as you can, you don't need to read this all, and this is not everything from the recommendation, but you can see that at least since 1997, that was the last millennium, EUB3730 is recommending maximum safe handling temperatures. We do have a recommendation in place that is on our website, but more has developed from that. And this is communicated in other terms as well. For example, in your company's safety data sheets. So the recommended safe handling temperatures, and I'll show them a bit more easily in a moment, are 200 degrees C for bitumen and air-rectified bitumen, and for severely oxidized bitumen, 230 degrees C. I'll come back to these temperatures and the background for these temperatures in a moment, but let me first introduce you into what is air-rectified bitumen, which is stated together with bitumen. As such, well, air-rectified bitumen is sort of an artificial name for a product that was basically created by EUB3730's members in order to differentiate between mildly blown binders and severely oxidized bitumen. So air-rectified bitumen go through the oxidation process, and if you want to know more details about the production processes for bitumen, remember we had an internal webinar on bitumen and its production. You can find the information on our intranet. Air-rectified went through oxidation, but it is only mildly blown. But because of the production process which involves oxidation, it is the same cast number as for severely oxidized bitumen applies, which is that cast number 64742-934. In the product properties, in the product composition, in the composition of the emissions, but also in the applications, these air-rectified bitumen are more similar to straight-run bitumen, which is the cast number 8052-42-4. We will come back to that in a moment, why this is important. So this is Air-rectified bitumen are products that went through an oxidation process, but only mildly. And they are applied, and they have similar properties to straight-run vacuum distilled asphalt. The differentiation between the oxidized bitumen, severely oxidized bitumen, and the air-rectified bitumen, and this took a long time to find a clear differentiation that everybody can apply, is done by the so-called penetration index. So the next slide shows you the penetration index criteria, and here you can see the formula for that. So you don't need to remember the formula. That's good news for today. The penetration index is calculated from the technical test parameters, that is softening point, ring and ball, and needle penetration, using the formula given here. Air-rectified bitumen have a penetration index of maximum plus 2.0, so below or maximum 2.0, while severely oxidized bitumen have a penetration index larger than 2.0. That is important to remember as the differentiation between air-rectified and severely oxidized bitumen. Again, you don't need to remember that formula. It's given in standards, and we can support you with this. So what's the background of the maximum safe handling temperatures? The emissions at work, the exposure of work, is determined by the temperature of use. The temperature is the key determinant, and this relates both to the amount of emissions, thus exposure for the workers, as well as for the composition of the emissions. Since the 1990s, but even before, a large number of research studies have been conducted that have shown that when work is conducted within these ranges of maximum safe handling temperatures, it's unlikely that the exposure to emissions out of hot bitumen would be hazardous to the health. This is really a large amount of research studies that have been done. They started back in the 1970s, 60s, 1980s. And then from the mid-1990s on, a large number of additional studies were conducted because the industry, but also the industry stakeholders, prepared for a review of the monograph on emissions from bitumen conducted by the International Agency for Research on Cancer, IARC. That monograph review took place in 2011. And in order to prepare the industry, but also the stakeholders, which included research, conducted further studies because some gaps had been identified, and developments took place in technical sense, and that was taken into account in order to have as much information as possible for the IARC monograph, which is a scientific review of available studies and available information related to the health of workers with a specific focus on cancer. So as I said in the beginning, Euratom is minimum since 1997 recommending these maximum safe handling temperatures. And I just want to give you two examples, two studies, or the outcome of two studies to demonstrate the effect of the temperature, A, on the amount of emissions, and B, on the composition of the emissions. Now, this is from a study, and you can find details on that in the document IS-230, the Bitumen Industry, A Global Perspective, which is currently under revision. This is from a study that was conducted by Price et al. And published in 2006, and it shows in this case for a 50-70 binder, but there are studies available also on other types of binders, the temperature dependence of the amount of emissions here given as total organic matter. And I think it very clearly. Remember that the total organic matter on the left-hand side is given in logarithmic scale. the amount of emissions from hot bitumen logarithmically depends on the temperature of the that is applied to generate these emissions. This applies similarly for different types, different grades of binders, and it's very obvious how important the temperature is. The temperature is also important with regard to the composition of the emissions, as I said before. Now, this is another study from 2006 conducted by Krieg et al. Also here you can find details in that document IS230. What you can see here is the carbon number endpoint versus the temperature in degrees C of the emission generation done for this study. The emissions, it's called fume here, but well, researchers use different terms. The emissions or the composition of the emissions is depending on the temperature. You can clearly see, and this is also shown in other studies, that depending on the temperature, there might be the majority of PAHs, polycyclic aromatic hydrocarbons, being more the 2 to 3 ring PAHs, while at higher temperature it's more 4 to 6 ring PAHs. Now, just an example for a 2 to 3 ring PAH. So one of these groups, that's for example naphthalene. Within the group of 4 to 6 ring PAHs, you have benzopyrene, which is a typical lead substance for PAHs, or for example crazine. Benzopyrene and crazine are classified as carcinogenic, and there is a concern that a large number of these 4 to 6 ring PAHs may cause cancer. This is not necessarily the case, or usually not the case, for the 2 to 3 ring PAHs, or in a different degree, so with a different classification on that. This study had also shown, it's not shown on this slide, but it has also shown that at temperatures below 200 degrees C, 4 to 6 ring PAHs, remember these are those where there is a concern of carcinogenicity, and some are classified as carcinogens. So below 200 degrees C as a temperature for generation of emissions out of hot bitumen, these 4 to 6 ring PAHs were not released. This is just one example. We do have more studies available on the temperature dependence of the composition of emissions. So we can summarize: the temperature is the key determinant on the amount of emissions, thus the amount of exposure, and the composition of the emissions, which the composition of the emissions is relevant for any potential health effects in there. And just one final remark before I move on about the temperature dependence of the amount of emissions. There's a publication available, for example, from the European Asphalt Paving Association from 2014. Now, this is with regard to the application in asphalt mixtures for road pavings. And they state that if the handling temperature for asphalt mixtures for road paving is decreased by 12 degrees centigrade, then that leads to a reduction of the exposure of workers by 50%, 50%, which is a lot. So we have identified the importance of the temperatures for the emissions, the composition and the amount of emissions. Now, coming back to the EUB3730 recommendation on maximum safe handling temperatures. For bitumen and air-rectified bitumen, EUB3730 and its members recommend that the maximum safe handling temperature is 200 degrees C. Remember, I said in the beginning that the properties and the application of air-rectified bitumen are similar to that straight-run vacuum distilled bitumen. That's why they are, and studies are available that show that the emissions from air-rectified bitumen and from straight-run bitumen are comparable. So it's safe to say that they are, for them together, the maximum safe handling temperature is 200 degrees C, while for severely oxidized bitumen, it's maximum 230 degrees centigrade. This is an information that is part of the registration dossier of for REACH in Europe. This information is given on the safety data sheets for the bitumen. And the use above these temperatures is also stated in the registration dossier as a use advised against, a condition of use advised against. I'll come back in a moment what that means and what the consequences of that are. But please keep in mind, maximum safe handling temperature bitumen, air rectified bitumen is 200 degrees C, and severely oxidized bitumen is 230 degrees C. Any use above these temperatures is a condition of use advised against. Now, moving over to what the consequences of these maximum safe handling temperatures are, that involves the users of the bitumen and so your clients. Temperature control is the key component to work safely with bitumen. So the lower the temperature in the application, in the handling, the lower the emissions, the lower the exposure at work is. A risk and hazard assessment should be conducted per workplace. And depending on the outcome of that risk and hazard assessment, engineering, organizational, or protective measures come into place. This is the responsibility of those who are working with the bitumen, so of the managers within the, for example, asphalt plants, of the construction companies, within the roofing plants, etc. So they need to conduct a risk and hazard assessment per workplace, and depending on the outcome, need to apply the appropriate measures. So there's a hierarchy for these controls. Usually we are showing pyramids in the other way around, so not standing on the tip, but it makes more sense for this communication. The hierarchy is pretty simple. If there's a hazard identified, and I'm not going to dig into details about what's the differentiation between hazard and risk, but if a hazard is identified in the hazard assessment, first one needs to check if that source of the hazard can be eliminated, so physically removed. If that is not possible, can it be replaced, substituted? If that is not possible, are there engineering controls? That is there a way to isolate the individuals, the workers, from the hazard? The next step of escalation is administrative controls, change the way people work. And the least effective one is personal protective equipment. So keep in mind that PPE, personal protective equipment, is not the first choice. It's the least effective and thus the last of these measures that apply. Now, breaking this down to the use of bitumen, in terms of assuming that people continue working with bitumen because it's an integral part in, for example, roofing membranes or in asphalt mixtures or in more than 100 other applications. So assuming that elimination and substitution of the material and of the hazard caused by the material is not possible, then the hierarchy of measures first starts with the engineering measures. This can be, for example, depending on the individual workplace, and remember that the hazard assessment is done per workplace. Depending on the individual workplace, that can mean that all operations, for example, around a truck, including venting, should be ground-based so that you are away from the source of emissions. Remote operations, Some of you might know examples, but so here's an example from Germany. Some of the equipment suppliers for mastic asphalt trucks offer remote openings of the truck to release the liquid mastic asphalt. So there's quite something ongoing on that. But this can also include local exhaust ventilation, so that the emissions are moved away. There's a ventilation, but also that exhaust that is taking the emissions away from the workplace. And again, temperature is key. The moment you lower the temperature, you will reduce the amount of emissions and thus the amount of exposure. So that is certainly also minimum an engineering control, if not a substitution control, because you work under different conditions when you lower the temperature. Talking about administrative or operational measures, that can, for example, include job rotation. Now, those of you who are familiar with, for example, paving sites, construction sites for road pavement, you will immediately think about, well, everybody's got their certain place, their certain workplace, they are trained for that. That doesn't work. Well, just because it isn't applied frequently, it doesn't mean that it cannot work. And we do know from extensive measurement protocols of measurements that have been conducted in a number of countries that the exposure of the individual at the individual workplace is different. So if you can conduct a job rotation, you can reduce the exposure for those who are more exposed than others. So just because it isn't done doesn't mean it cannot be done. It's something to think about. It's not the only measure, but it's something to think about. And when it comes to protection, that is the least effective, as we said before, depending on the workplace hazard assessment, of the adequate PPE will be defined, and that may include respiratory protection. Now, for example, when it comes to the release of hydrogen sulfide in emissions, depending on the industry and depending on the individual situation, people do wear monitors, and at some places people do wear respiratory protection. That is definitely not something that is not easily acceptable for the workers. They don't necessarily like to wear respiratory protection. And some people also discuss about, and these are fair points, well, what's the perception of the general society if we, a nightmare, had a construction site at a highway where every worker was wearing respiratory protection? Well, that's not what this says. It's depending on the individual workplace that hazard assessment needs to be conducted, and it might be that under certain conditions it is advised to foresee respiratory protection. And that doesn't necessarily only apply to the hazard coming from any potential hazard coming from emissions out of hot bitumen. That can just as well apply to emissions, for example, from the traffic on a highway construction site. So diesel engine exhaust is classified as carcinogenic. So also that is part of the hazard assessment and needs to be addressed by the managers, by the responsible persons. So EUB3730 has conducted a number of, or has made available a number of safe handling guidances and information for members. You can find them on our website, www.EUB3730. If you go into and this is a screenshot of our current website, if you go into the section publications, you can choose by document type, by country, by language, but you also have, as you can see on the right-hand side, a search word where you can enter a keyword and find the documents. There's a large number of safe handling guidances that we have available. As you can see here, for example, the pocket guide on H2S, So this is about protecting workers from exposure to hydrogen sulfide. But we do have our safe delivery guide, we do have the burn scars, we do have a large number of safe handling guidances available. And also on that, we did have a webinar already. Oops. It's a bit strange with this presentation mode here. Check for these, they are frequently updated. Last year, we updated our guidances on hydrogen sulfide. This year, we're going to update our guidance to the safe delivery of bitumen. And in these in these documents, we communicate the maximum safe handling temperatures, which brings me to the conclusion of today's webinar in terms of the presentation. Just to remind everybody, for bitumen and air rectified bitumen, the maximum safe handling temperature is 200 degrees C, for severely oxidized 230 degrees C. As stated before, I also wanted to talk a little bit about what are the consequences of this, because these temperatures are part of the registration dossier under REACH, and they are stated as working above these temperatures is a condition of use advised against. And there are legal consequences from that. If a company, if an individual is working under conditions of use advised against, there's more responsibility for that person to work on that. It doesn't mean that you cannot work above these temperatures, but the responsibility is with the responsible person at that company, at that work site, to ensure that working beyond these conditions is still safe. So the company, for example, needs to it's called under REACH, it's called the downstream user. The downstream user needs to run a chemical safety assessment, and they need to demonstrate that the use is safe. They need to demonstrate that the use is safe. So if, for example, and this is another practical example, I'm from Germany. In Germany, mastic asphalt is produced using air rectified bitumen. So usually you would say the maximum safe handling temperature is 200 degrees C. But in Germany, mastic asphalt is applied at 230 and sometimes even above that. That is beyond the maximum safe handling temperature for air rectified bitumen. And it is within that condition of used advised against. So everybody who is working with air rectified bitumen beyond 200 degrees, so above 200 degrees C, needs to conduct a chemical safety assessment and needs to demonstrate that the use is safe. EUB3730 members have good reasons to state that within the ranges given here, that is 200 degrees C for bitumen, air rectified bitumen, and 230 for severely oxidized bitumen, the studies available to us did not show that there, or did indicate that there's no hazard to the human health when you're working within these ranges. We cannot take any liability and responsibility for any working beyond these and above these ranges. That's why they are registered as condition of use advised against. And we strongly recommend to the downstream users and to the industry stakeholders, our partner organizations, to respect these maximum safe handling temperatures. They are important. They are important in terms of the amount of emissions, thus the amount of exposure for a worker, but also with regard to the composition of the emissions, the composition of the exposure. I presented before that, for example, with regard to those 4 to 6 ring PAHs, of which some are of concern with regard to carcinogenicity, they have not been found being released at temperatures below 200 degrees C, but they have been found at temperatures above. We do have, I mentioned the IARC monograph before, we do have a statement in the IAC monograph that the emissions at paving and the emissions at mastic asphalt application using straight run bitumen and air rectified bitumen are probably carcinogenic to human, while the emissions to oxidized bitumen at roofing places or for roofing applications possibly carcinogenic for humans. We do have a regulation in Germany in place where there's an occupational exposure limit for working with straight run bitumen and air rectified bitumen, an occupational exposure limit on the emissions out of hot straight run bitumen and air rectified bitumen, while the emissions out of oxidized bitumen in Germany are classified as carcinogenic. So this is really something to take very seriously from the point of view of protecting the health of the workers and protecting everybody, the environment and the human health. But it's also important to take into account from a legal perspective. Bitumen is safe to use when it's handled properly, and the maximum safe handling temperatures play an important role in that. That's been the presentation I have prepared to give you on the maximum safe handling temperatures, the importance of the temperatures, and the guidances Euratom has available and support Euratom is giving. If you have any questions, I'm happy to try to answer them. If you have any questions, remarks, need further information, you can here see a list of the Euratom team members and the contact details. Please feel free to reach out to us. And with that, thank you very much. I'm looking forward to the discussion, and it's back to Ian to stop the recording and to change the